Hello, so here's the problem number 2 of second 3 assignment, and in this problem we have to convert given binary tree or binary search tree into doubly linked list. So actually it doesn't matter if either it's a binary tree or binary search tree. We will be using the same approach. In order to convert this tree, we will be just using the tree node class left and right pointers. We will be considering those pointers as previous and next pointers of linked list class. So for example, given this tree node class, we have left and right, and those pointers will be considered as previous and next pointers respectively. And at the end we'll just return the header of our linked list. And in order to solve this problem, we will be using in-order traversal approach of a binary tree, but the lack of this approach, we will be initializing header pointer at the left side, and by implementing in-order traversal, our header will be moving through all the nodes of a tree, and at the end it will be end up with the last node of a tree. But our goal is just to implement this approach so our header will be at the first node, so at the end this given binary tree will have this output as a linked list. So our header should be at the beginning starting with one value. So in order to avoid this problem, actually we will be using reverse in-order traversal approach. So this means that we will be applying in-order approach starting from the right subtree rather than from left subtree. So actually we will define our head pointer at the beginning as null on the right side, and we will have our function which we will call it always recursively, since we will be using in-order traversal approach. And at the beginning, once we will get to this node, our left pointer will be pointing to this left node, because our left is actually our previous and our right is actually our next pointer of linked list. So our left will be pointing to this last node of a tree. Then also this node's right will be pointing to null. Then we will be moving our header to this node. So our head will become equal to this, will be pointing to this node. Then we'll come to this node. We will be doing the same. We will be pointing our left pointer to this root, and root's right will be pointing at head, and then we will move our header to this node, and again our header will be moving from most right to the left, and at the end when we will be ending with the most left node, we will be just return our header. So let's go to our code. So our code will be returning tree node, and I will call it convert binary tree to W linked list. So input will be root, and at the beginning we will just define our head pointer. The initial value will be null. At this time we will just call our helper function, where we will be passing our root and head pointers, root and head nodes, and our helper function also will be returning tree node, passing root and head, so if root will be equal to null, we will just return header, then we will define header to the node which we will retrieve from the calling helper function recursively on our right subtree. So basically here we're calling our right subtree of our tree, and each time we will go to the rightmost node, and after that we will just define our header, and after that we will be moving our header to the left. Then once we will get the rightmost node and we will define it as a header, we will since our right is a next pointer, our root next will be pointing to our head, and if head will not be null, so if there will be some value, it will be pointing at particular node, our head previous pointer also will be pointing onto the root itself, and then we will be moving our header to the root. So basically it's just the first step. When we will reach our rightmost node, then we will declare our head as a null, and then our head previous will be pointing to the our rightmost node. Our rightmost node's next pointer will be heading to the pointing to the head, and then we will move our header to the node itself, and the same thing will be done when we will be considering this node. So, and we'll keep continuing it until we will reach the leftmost node. And after that we'll just return the helper, where we will be passing the left subtree of our given tree. So here we'll just passing the root left and the head just to move it accordingly. across the all nodes of a tree.